Okay, so now we can start with the discussion of the Google Trends parts of the application integration. So as we can see, this is the general layout. This part follows. So basically, the Trends adapter is subscribed to the iEnrich queue, and every time like a message gets published in the queue, it gets the message. We want to note also that, as we talked about before with the iEnrich queue, the data is enriched with a category value, and we use this category to enrich the data with the trends value of such category value that goes from 0 to 100. Then the data, once is enriched with the trends value, is published in the Trends API queue as a message, which will be then consumed by the translators adapters. Generally, we use 3 different trends application. I know you may be asking why so many, what's the need? We'll get into it in a bit. It's important to note that all the applications we chose are free or have a pretty substantial free plan. So the first one is called PyTrends, which is an official Python API to Google Trends. In this case, the adapter sends an API request, and it gets a response with a lot of data, including trend value. So basically, the data gets back, it goes through a content filter, built-in content filter, and then only the a trend value from 0 to 100 is kept. Similar is done with our second trends application, which is SERP API, which some of you might know. We put this as second, as this is one of the few applications we found that offer a free trial of 100 requests, which is more than the other services that we found. Basically, in this case, it follows a very similar process to PyTrend, as we make an API request, and then we get a response. We filter the data, as we don't need everything. We just need like a trend value, and then this data is added to the output message. Lastly, we also use a static dataset, which we found on Kaggle. So basically, the static dataset has like various trend data for different keywords among the years. In this case, then the dataset is downloaded locally, and the data is taken from the dataset as a keyword with a respective trends value. In this case, the trends value ranges from values of 0 to 5. So in this case, we also need the message translator to very simply translate this 0 to 5 value to a range of 0 to 100. So the question may arise as to why we need so many applications. Well, the idea is that we started with PyTrend, as it is completely free. The problem with PyTrend is that it's tied to Google backend changes, so it's an official API. So in case Google changes something in the backend, then the application, like the API, stops working, and is very often blocked by Google rate limit. We try to limit that through the use of different proxies, but this proved often unsuccessful, to the point that the more we start testing with it, the more blocked we got. So then we fell back as a second option to SERP API, which, as we said before, has a free plan of 100 requests. SERP API again was working perfectly as the second option. The problem here, as we can see, is the uptime of the API from 0 to 100% in the past week and a half or so, which basically is 0. This was very unexpected, as we started working when the API was here, so it was commonly getting data. So basically, we needed to have a third fallback option, and in this case, we use a static dataset, which is not the best idea, of course, but since Google Trends doesn't offer like a open API, let's say, we needed a fallback option, which we knew that could always work in case the previous two didn't. So in this case, like, it's always available in case of failure of the service. It is not the best solution, since it also has a limited, while large, has a limited amount of keyword. In case we don't find a keyword for a category that we're looking for, then we use cosine similarity to get the closest word for its value, and then I get the trend value of that. Are there better solutions to this? Yes, but from what we found, they were very expensive, a budget that we simply were not able to afford for the course.